Hello, welcome back everyone. Today we're going to cover chapter 5, which includes time value of money concepts such as compound interest and its effect on inflation and return. In this chapter, you're going to learn about opportunity cost and the time value of money. You'll understand how compound interest work, and we're going to go over several calculations, including future value, present value, annuity, and it's okay if you don't understand these terms. We're going to go over that in this chapter. The most important part is to apply the time value of money concept that you learn to your personal financial planning. And you will learn how to analyze the impact of inflation, the impact of interest on borrowing, as well as return that you earn on your investment. We will also talk about different types of interest rates and also what are some important political and economic factors that may affect interest rate and that will also affect your personal life. So let's get started. First, let's take a look at opportunity cost. Opportunity cost is an economic concept, and it is involved whenever we have to make choices. So let's take a look at some example. Here are some possible choices. When you are deciding what to have for lunch, let's say you can choose taco or you can choose pizza. You have a few hours. What do you want to do? Do you take a nap or do you go to the gym or go for a run? Spring break is coming up. Do you want to work extra or do you want to take a vacation? All these are choices. And economists define opportunity cost as the value of the next best alternative when you make a decision. So let's take a look at what does that mean. In this example, the opportunity cost of having taco for lunch is giving up pizza. And the opportunity cost of going for a run is not taking a nap. And when you think about your vacation cost, the cost of your vacation over spring break is not just the cost of the trip, but it also should take into account the money that you could make by working, because the money that you could make by working is the opportunity cost of taking the vacation. And for economists, when we make a choice or make a decision, we need to take into account opportunity cost. There's a saying in finance that $1 today is worth more than $1 tomorrow. Why do you think that's the case? Pause the video and think about it for a minute. One thing that all of us noticed recently is inflation. So if prices are going up, then things are more expensive tomorrow or a few days later or a few months later. So $1 today can buy you more things than it can in the future when there is inflation. Another reason is because of opportunity cost. The money that you spend today means that you could not invest that money and earn interest or return on your other investments, such as mutual funds or bonds. So when you think about spending money today, you're also giving up. So giving up is the opportunity cost of earning return on that money. So when we make decisions about saving money and spending money, we need to take into account what your current needs are, uncertainty about the future because of inflation, also potential return on your investments. Next, let's look at the concept of compounding. This is one of the most important fundamental concepts in finance. The key assumption behind compounding is that return or interest on money that you owe is computed based on the most recent balance. And compounding simply means that you can earn interest on interest if you are investing the money, or you will be paying interest on interest if you are borrowing the money. Let's take a look at a simple example. Let's use some simple round numbers. You're investing $1,000 at 10% per year, and it's compounded once per year. We'll explain all that concept later on. Compounding once per year means that at the end of each year, interest will be computed on your investment. So in 1 year, $1,000 at 10%, 10% is 0.01, is $100. And after 1 year, the balance in your account will go up to $1,100. So $1,000 of your original principal plus the $100 in interest will give you an ending balance of $1,100. Let's say you don't need the $1,100 right away, so you leave the money in the investment for another year. How much will you have 2 years from now? So your return in year 2 is based not on $1,000, but on the new balance of $1,100. So $1,100 times 10% is $110. After 2 years, the balance will now go to $1,210. So you started with $1,000, you earn $100 in year 1, $110 in year 2, and you end up with $1,210. The compounding happened in year 2 when you're earning 10% not just on $1,000, but earning 10% on $1,100, meaning you're earning 10% on the $100 interest that you earn in year 1. To fully appreciate the impact of compounding, we also need to look at a concept of simple interest. Simple interest happens when the future interest is not reinvested. So what that means is the balance is assumed to remain the same and no interest is added to the outstanding balance. Once again, you can invest $1,000 at 10% per year. The simple interest is 10% on $1,000, so it's $100 per year. The assumption is that you will use up that $100 or that the contract of the investment says, no, there is no compounding. With simple interest, your total interest is however much you earn per year times the number of years. So over 2 years, it will be $200. And the balance at the end of 2 years with simple interest, so no reinvestment, no compounding, will be $1,200. It may seem a small difference over 1 year, but the effect will be very different over a longer time period. The term compound interest technically refers to the interest on interest, and you can compute that by subtracting the balance with reinvested interest versus the balance with simple interest. In our example, the balance after 2 years with the reinvested interest is $1,210. With simple interest is $1,200. So the compound interest, so the difference is only $10. And the $10 comes from earning interest on interest. So 10% on $100 is $10. So that is the compounding part. The most important power of compounding comes in when there's a long time period. In the same example, with $1,000 invested at 10% per year, but now over 30 years, the impact is much greater. The balance after 30 years with reinvested interest is $17,450. With simple interest, meaning no reinvestment, is only $4,000. The compound interest that is due to compounding, meaning interest on interest, is $13,450. That is greater than the simple interest. We'll go over how to do this calculation over multiple years in the next few slides. Here's a graph showing the power of compounding. So this is the ending balance for $1,000 earning 10% per year. If you invest for just 1 year, but this is all with reinvestment, versus 30 years. You can see the power of compounding increasing. And if you are looking at the interest, simple interest will be just a simple straight line. In understanding compounding, it's important to also recognize something called compounding frequency. Compounding frequency is a time unit. So it can be a year, a quarter, a month, a day, minutes. Compounding frequency means how often is interest computed per year. So if interest is computed once per year, it's called annual compounding. If it's computed 4 times a year at the end of each quarter, it's called quarterly compounding. If interest is computed at the end of each month, it's called monthly compounding, and so forth. So if interest is computed once per year, then the compounding frequency is 1. If it's quarterly, that means it's 4 times per year. Monthly is 12 times per year, and so forth. There's a special case, it's called continuous compounding. We will not use that in this class, but just so that you'll be aware. So why is compounding frequency important and why do you need to know about it? That is because compounding frequency oftentimes coincides with your payment frequency. Think about the higher the compounding frequency will result in a higher, something we call effective interest rate. We'll demonstrate all this concept with actual examples. So think about in your daily life, how often do you need to make payments? Most of us have to make payments on a monthly basis. Sometimes, for example, water bills are paid on a quarterly basis. So those are how often you make payment is oftentimes coincide with compounding frequencies. Now we come to the fun part of this chapter, which is how to compute time value of money. You'll learn how to compute all the numbers that we showed you earlier in the last example. In this video, I'm going to go over most of the concepts. And then in the next video, I'm going to go over how to do all these calculations using spreadsheets. Before we delve into the calculation, first some definitions. We'll be using these terms over and over. Present value is defined as the beginning of your investment horizon, and I'll use the abbreviation PV for that. Future value, or FV, is the value at the end of an investment horizon. It can be an investment or it can be a loan. So this is how much you owe when you borrow in the beginning and how much you still owe at the end of the time period. The compounding frequency is how often interest is computed. And time is the time unit. So we'll use 0 is today, 1 is period 1. So if your compounding frequency is monthly, then 1 will be month 1, 2 will be month 2. If it's annually, that means year 1, year 2. Rate, R, is the rate of interest on the investment or the loan. This is the only formula that you'll see in this chapter. Here it says that the future value, so that's the ending value of the investment, so how much you have at the end at some time in the future, is equal to the present value, 0 is today, so it's how much money you have today, times 1 plus the interest rate raised to the time period. Since using a calculator will make this very, very easy to do. So let's use an example. In the last example, we were investing $1,000. So that is how much money we have today. So that's the beginning. So that present value is $1,000, and the compounding frequency is once per year. Interest rate is 10%, and we invest it for 2 years. So the present value is $1,000. So future value equals to $1,000 times 1 plus R. So 1 plus R is the interest rate. So R here is 10%. So that's 0.1. And raise it to T. T is the time period. Here is 2 years. So that will be $1,000 times 1.1 to the power 2. Pause the video and use your calculator to check the results. Do you get $1,210? And that is the same amount that we saw in earlier. Remember, we walked through step by step on how we come up with $1,210. So the formula is simply a shortcut. It is not magical. And you can use the formula, or as I mentioned earlier, in the next video, we'll show you how to use Excel or Google Sheets to do the same calculations. Now you have the tool to compute future value, not just 2 years, but also for 30 years. So all you have to do is change this from 2 to 30. So if you multiply 1,000 times 1.1 to the power 30, so instead of 2, 30, you will get the answer for future value after 30 years. You can use the time value of money concept to compute many different types of cash flows that are important in personal financial planning. For example, you may want to find the future value. That process is called compounding. And you can use this calculation to find out how much the ending value is for either an investment or a loan. You can also find the present value, and that process is called discounting. You can use that to find out what the starting value is for a loan or how much an investment is worth. That is the most common use of discounting. You may even have heard of the term discounted cash flow analysis or discounted cash flow. That is what they mean. When you do discounted cash flow, you're computing the present value. We also want to distinguish how many cash flow are we evaluating at a time. A single cash flow in finance is called a lump sum. And one of the example that you can use a lump sum for is adjusting for inflation. Let's say you know how much something will cost today and you have an idea on what the average inflation rate may be. You can estimate how much that thing will cost in the future. So when you're planning for retirement, we know that we'll need more money than today to finance our retirement in the future because things are going to be more expensive. But how much more? Using this approach, you'll be able to estimate that. In contrast to a single cash flow, an annuity is a finite series of fixed equal payments, and they have to occur at regular intervals. So you have many payments, multiple payments, but they are all of the equal amount. Another important assumption is that interest is computed or compounded at the same frequency, which means that each time a payment is made, interest is recalculated. Annuities is a very common form in consumer finance. Mortgage payment, auto loan, all those typically have fixed payments and equal amount, and you have to make the payment on a monthly basis. Sometimes you may not make exactly the same amount. For example, planning to save for retirement. You may not be able to save exactly the same amount every single month. But assuming a fixed amount will make your planning easier. Even if you don't make precisely the same amount, as long as you're close, that is good enough for planning purposes. There are two types of annuities. If all the payment occur at the end of the period, it's called an ordinary annuity. This is the most common form, and that is why it's called ordinary. Car loans are usually due at the end of the month, as well as mortgage payment. If the payment occurs at the beginning of the period, it's called an annuity due. These are also very common. Rent payment, lease payment, if you lease a car or you rent an apartment, the rent or the lease payment is due at the beginning of the month. So those are annuity dues. Perpetuity is an ordinary annuity that lasts forever. The mathematical term is called infinite series. What that means is you can set aside a lump sum of money today, and that will finance an equal amount of payment that can last forever. A lot of trusts are set up that way. Something that you may have experienced yourself is a scholarship. So a donor may donate a large amount today, and that amount will be able to generate scholarship payment for perhaps eternity. The last type of cash flows is called uneven cash flow. It just means that you are trying to evaluate multiple cash flows and they all have different amount. This is probably the most realistic because things seldom happen identically time over time, month after month, but it's not as useful for planning because the extra reality makes the calculation a lot more complicated. Being able to evaluate uneven cash flow is important for verifying what actually happened over time. And that is beyond the scope of this class. And we will, because this class focus is on planning, we definitely will cover uneven cash flow in a more advanced finance class. We'll end the video here. In the next video, we're going to come back and we'll learn how to do this calculation using Google Sheets instead of using formulas. And you'll make things a lot easier. See you soon.